Welcome back, everybody, to part 3. Hope everybody's doing well. I'm feeling a lot better. I think I've got the crud behind me. I hope I don't have a back set. I'm going to take part 3, and I think I'm going to dedicate it strictly to the speaker itself, in the repair of it, or the attempted repair of it. Excuse me. And also this first part, and this is a disclaimer, this first part is more of an experiment than actual knowledge thereof. So I really don't know what has happened or is happening. This is the second time it's happened to me before, and I suspect that this meter may be not the problem, but an issue. That is, I've starting to read blurbs of it on ARF, and also Don, Restore Old Radio's video, one of his Philcos that he worked on had a similar issue with, but he had a different fluke. But what I've been reading is that sometimes a new digital multimeter, when it's in the auto range and you're testing an inductor or a coil or something like that, it gives erratic readings because of the circuitry. Now, don't ask me to explain it because I don't know. I really don't know. This Philco speaker, originally the voice coil, the field coil was 1200 ohms. Well, in an upgrade and update, it went to 2600 ohms. Okay, when I first checked this field coil, it was right on the order of 7600 ohms, and since then I've checked it several different times, and it went up to like 11K. That, if you'll remember back on the Colorama, I experienced something very similar on the output transformer. So I've got a post out on the Antique Radio forums asking questions about it right now, and I'm trying to figure this all out. I'll show you an experiment. Dave McClellan, I talked to him yesterday, and he gave me a little experiment to try, and I did try it. And what I did is I basically built a variable DC power supply using my Variac. I used 4 diodes in a full wave bridge, and you can use 1N 4 002s, 3s, 4s. But I had some on hand that was, don't even know the numbers of them, but they were 1 amp at 750 volts peak inverse voltage. So I used those. They'll work fine. I used a 22 microfarad capacitor at 450 volts. And of course you come up with your positive and negatives. Now what I plan to do is start this at 0, start my DC voltage at 0, feed it into the field coil, monitor the current of the field coil itself. Not going to get over 40 milliamps. I believe, based upon, I don't have it written exactly, but looking, the best of my calculations, 56, 60 milliamps is probably the max of the field coil. So I'm not going over 40. Okay. And we'll also inject a signal into the speaker to hear it. So I'm going to run this up to 40 milliamps. We're going to have a tone in here, and you'll be able to hear it without the magnetic initially. We'll fire up the Variac, raise this voltage up, but mainly watching this the current, making sure we don't exceed 40 milliamps. I think we could probably go to 50, but I'm going to be extra cautious, because if this is good, I don't want to tear it up myself. I tear enough up without unintentionally instead of intentionally. So what we'll do is we'll look at this current, We will then look at this voltage, then we will do the calculations of Ohm's law and see what the resistance is. Okay, does that make sense? All right, let's see if we can get into trouble here. That's about a 600 hertz tone. I'm sorry, 600, yeah, 600 hertz tone. So, let's make sure my variac is down. Tell my wife to go ahead and call 9-1 and then just get ready for that last digit. But let's go. All right. We're going to come up. There's 2 milliamps. And we should hear the volume. And I think I already heard the volume go up. So if it's working, the volume will go up because the magnetic field will be getting stronger. So you help me listen for it also. And watch this dial. Do not let this go over 40. Okay, there's 10. Hearing the volume? I hope that's not aggravating. So there we're looking at 40 milliamps. And we'll call that 114 volts. So, cold at 40 milliamps at 114 volts, that's 2,850 ohms. That's pretty close to that 2,600. Everybody agree? So I think the thing's good. I think I've been getting erratic readings here. Tell me what you think. Give me your ideas. Now let's tear into this speaker and see if we can repair it. Now after it's disconnected, reading right around 3,200 ohms. What's different, guys? Okay, I'm going to start working on this. First thing I'm going to do, I'm going to try to repair this. We'll see how this works. I'm going to remove some of this fingernail polish. Now don't ask me why I come up with that. Well, I can tell you why. Rebel Gary up in Indiana, Rebel 9668 made a suggestion about taking it off. I don't believe I'll take it all the way off. I don't want to saturate the cone that much, but I'm going to try to take some of it off so that my patch will take hold. Now this is very, very brittle. And is this going to work? I do not know. You're seeing it live time right here, folks. If you stick a finger through this way, if you stick it through this way, will it counteract it? Now I've stole my wife's acetone and her little pump that I bought her. And I'm going to try to just reduce the amount on that a little bit. I don't know that that's going to work. But then I'll show you how I'm going to go about patching this. And we'll see if that works. I'm getting a little bit off there. We'll just take that off. Let me work on this off camera. I don't think you want to see this dry. Paint drying or fingernail polish removal. Got up this morning, something was on my mind. I was thinking about an old mentor of mine back in the 70s. He passed away in 2002. I've had several electronic mentors over the years, but it just this morning, I hadn't thought of him in a long, long time, but I don't know. Something just made me think about him this morning. And his name was, he was a very unique individual. And he really impressed me. Really impressed me. I met him back in about 74. And he worked for NASA. Well, he worked in Huntsville, Alabama, with the Space and Rocket Center. Well, you say, well, there's a lot of people that do that. Well, he was an electronic technician. And what was so unique about him, now he worked on all the Saturn and the Moon projects and all that stuff. Just an encyclopedia. You just ask him a question, he could tell you something about it anyway. And what was so unique about him was he had a 6th grade education. 6th grade education, working for NASA, Moon Project, Space Program. So you know he had to be exceptional. And what he did, and I think it's funny, I really do. The engineers would draw up plans for devices that they would use on the space program. And they would tell Bill, his name was Bill Holcomb, and they would tell Bill, this is what this does, and we need the current and the voltages and all this stuff, and this is what it does. Well, he'd take the drawings and he would build it. And then he would backfit the parts to make it work to specs. And then he would mark up the drawings and take it back to them, show them what he had, and they would change the drawings, and that's what they'd do with it. He had a lot of interesting stories about the space program, but it was just something I thought of this morning. Okay, we'll let that dry a little bit, but what I'm planning on doing is I'm going to go all the way back into here and just put a big patch. Yeah. So what I did is I took a bun coffee filter. Now I like buns. Don't ask me why. Well, there is a reason. I'm glad you asked me. They have a lot of extra fiber in them, and you can really get the fuzz to come out on them. So I cut a wedge out, and then I measured it down in here till I found my diameter, and then I rounded off on that, and now I'm going to cut that around the edge. And then I'm going to apply it. Now I know y'all have seen this dozens and dozens and dozens of times, but I thought I would show you this. Let me pause it and mix up my brew. Okay, I usually don't cut this to shape, but I did just to do the general shape of it. So now what I'm going to do is I'm going to tear it a little bit to get the irregular corners. Okay. There's a reason for this. You're saying he's crazy. Now you can still say that. Anyway, just tear it away. And I think you'll see what I'm doing. The method to my madness is there's fibers, and they reinforce. Now Michael from That Tube Sound put me onto this, and it has worked very, very well for me. Best ball has been very, very good to me. And people who goes back Saturday Night Live will know exactly what I'm talking about with that phrase. Alright. Now the game plan here is to take a brush, which I usually have an extra one right here. This is my cheap Dollar General store brush. I have mixed my wood glue a little bit more, about half and half, so it's a real runny. and you want to paint it on the surface. Now that's the reason I wanted to try to take that fingernail polish off so that would absorb, but I'm afraid I'd take the whole thing out, so I'm just going to have to live with what it is. And so just going to put that on there like that. Then I'm going to dunk my patch in here. Okay. Then we're going to get a little excess off. Don't want it to run down. Well, it's going to run down anyway. And we'll get a little extra paper towel. And I just roll the paper towel all the way across the room. Nobody at home ever does that, I'm sure. Yeah, but this is real life stuff, guys. So we're going to try to do our best. That's all you can do, as John from Arkansas says. Just do your best. That's all you can do. That's all you can do. And then you want to smooth this all out. And we're going to have to make this work. It's having to fill in places that it's not there. And I can feel the thing giving. I don't like it on that spider, but it doesn't, I don't think it's going to matter. Really don't. You can see the fibers that I'm spreading out will help adhere and hold that. And that's pretty much it, guys. Is it going to be perfect? I don't think so. I mean, there's a lot of damage to that speaker, but we'll let that dry. Okay, it's starting to dry a little bit, and you see that it's coming around, and we'll look at it after it's dried. But I want to take one of the suggestions from one of my subscribers, John Sweida. John suggested that I'm adapting this, John, so changing it just a little bit. We may end up doing what you suggest. He suggested getting a cone about the same size and just overlapping it maybe on both sides. So I'm going to use both sides, but what I did is I went ahead and cut me a patch to go on the back side. I'm able to access it because of this large opening here. So I'm going to apply a patch on the back side just because it's actually missing here. It's not, a lot of these cases that when you patch them, you have the crease, and all you're doing is bridging that crease or that tear. This is you're actually bridging a gap. So I'm gonna reinforce it with the back side also. So here we go with that. And I appreciate John suggesting this to me. And I suggest any of the suggestions I have, I listen to them. I'll read them, and I'll evaluate whether that's what I want to try or not. So, but I always appreciate feedback. And like I've always said, feedback is always good. And there's a right way and a wrong way. You don't have to be ugly with feedback, and I haven't gotten any, and that's a good thing, and I appreciate that. But at work, we used to get a lot of ugly feedback, so negative feedback, and delivered in a very bad way, bad delivery. The delivery means a lot, So let's see if I can kind of levitate that back in there. You didn't know levitation was necessary in some of this stuff, huh? Now I really need my X-Acto. Now, you're never supposed to get your arm in front of the camera, but that's what they tell you, and they'll fuss at you. So. But anyway, sometimes, you know, I'm not as prepared going on camera as I should be. All right. There's that. Paper mache, I guess, huh? That should help reinforce that quite a bit. I want to make sure I get the air out of it. I don't want it to have a bubble inside where it's banging around. But I think that's going to work out pretty good, guys. When this thing dries, I'll hook up my power supply on this, and we'll feed some audio into it, maybe even some real audio into it. We'll see how that works. Figure out a way to do that. Okay, let's let that dry. Alright guys, it's dried. Pretty rigid. Let's look at the back side, see what it looks like. May not look the best in the world, but it's a solid piece now. So let's tell you what, let's hook up. Let's rewire it. Let's hook it up. All right, make sure we got good connection. You know the routine. I'm gonna run the voltage up. Let's go ahead and put some audio on it. It's down about, that was about 200, I believe, about 200 hertz. Probably can't hear that there. All right, let's bring this up to about 40 milliamps. Yeah, let's see. Okay, there's about, well, let's go back to 40 exactly. Right, there's 40 milliamps, and I'm running at 100 and we'll call it 117 volts. Now we can do the math and see what that is. All right, there's 200 hertz. 400, 600, 7, 8. Excuse me. There's 4K, 5K, 6K. I'm starting to lose it about 65. You may hear it, I don't know, but I start hearing it about there's where I start hearing it. That's a little over 6,000 hertz. All right. So there we go. 40 milliamps at 117 volts. I'd have to do the math. Let me do the math. Okay, I touched it up. It was 40 milliamps at 118 volts, and that comes out to 2950 ohms. I ran it through the spectrum. Had fairly decent range, so we're gonna go with it and see how it works. So we'll conclude this. The next series, we're going to jump in that cabinet. We're going to do some resistance checks. Check those things out. Try to get that capacitor box back in and start taking out those block capacitors and cleaning that mess up in there. So, hope you enjoyed this. To me, it was a pretty good experiment, and I learned something. Hope you guys did too. And so, from Larry, from the hills of Tennessee, thanks for watching. Okay, one more thing. One more experiment. Feeding audio into just the voice coil itself with the power applied to the magnet. Maybe I can get that. All right. About a mile off Old Mill Road. That's by nobody. Okay, that's it for now. Thanks for watching.